Welcome to AlphaNumericTricks. Today we are going to see problems under equations reducible to standard forms. We have done 4 set of problems here in the last videos. If you want to please go through it. Now we are going to see find the complete solution of 4z squared q squared is equal to y plus 2zp minus x. For this problem we have to find out the complete integral using easy method, that is equations reducible to standard forms. We have to do it. Now we see the problem. Find the complete solution of 4z squared q squared is equal to y plus 2zp minus x. And before going to start answering, you have to identify the type of the problem. Okay, so you have to number this as equation 1 and you have to identify the type of the problem. Here z, p, q, x, y, all the terms are present and it is not in the Claridge form. So definitely this problem comes under equations reducible to standard form and not any of the remaining 4 types. Okay, because 4 types, first type you know that first type is this alone is present, f of pq alone is present, and second type is if it is all the terms are present, it should be in the Claridge form. It is not like this. And third type also we have these terms alone is present, and the fourth type is separable equation is it is not present, but here this is not coincide with any of these 4 types. So definitely this problem comes under equations reducible to standard forms. Okay, after that you have to go for our substitution. So we had to take like this, we have to simplify this terms, that is you have to, I already told you that we have to take pq terms one side and the xy terms to constant xy terms to other side before going to your substitution. Okay, so we had to take this 2zp to other side. So here this 4 can be written as 2z q the whole square. 4z squared q squared can be written as 2zq the whole square, and minus 2zp, that is 2zp is taken to other side, it becomes minus 2zp is equal to y minus x. Okay, and in the last videos we have seen that y minus x, y plus x is present. You have to retain that in the right hand side itself, don't take to the other side. So here also we do the same idea. Here we have to substitute that. After that you have to go for the substitution. P and q, p is equal to dou z by dou x and q is equal to dou z by dou y, and remaining terms you have to write as it is and number that equation as 2. Okay, after that you have to go for the substitution, isn't it? So we have in our problem you have a z dou z is there, so you have to take z dou z, we usually take it to be dou capital Z, but both the terms having 2z, isn't it? So we have to take 2z, dou z is your substitution, dou capital Z. So dou capital Z is equal to 2z dou z. Depending upon the problem only we have to choose this, then only your simplification becomes easy. Okay, and then here you have to take this x is equal to small x is equal to small, that is dou small x is equal to dou small x, and dou small y is equal to dou small y, we take as it is, or otherwise you can take this to be capital X and capital Y, and you have to replace all the terms, small xy terms to capital X and Y, and you have to finally you change the all the terms. Okay, both the ways you can do it. Now you have to integrate this. Okay, when you integrating, integral dou z as z, which is equal to 2z squared by 2, and that is 2 is there, z dou z is the integration of z dou z is z squared by 2, and this 2 to get cancelled, so remaining z is equal to z squared alone you have to substitute, and we have to substitute the terms here. The 2z dou z is replaced by dou capital Z by this dou y the whole square minus this term 2z dou z is replaced by dou capital Z by dou x is equal to y minus x. Okay, this is our after substituting all the terms, this is our simplified term. If you want you can take this to be, when you're using this way you have to replace this as small y by capital Y and small x by capital X, and in final answer all the variables should be replaced. Here we do only one thing, z alone we changing, remaining terms as it is. You do whichever method you feel easy. Okay, and then we take the substitution. Capital P is equal to dou z by dou y, and capital Q is equal to dou z by dou small y. Then your problem becomes, here this is our problem now. The dou z by dou y is q squared, capital Q squared minus, okay, this is P, isn't it? Q squared minus P is equal to y minus x. Okay, Q squared minus P is equal to y minus x after substituting this capital P and Q values here. And this problem we have P, Q, X by alone is present. So this is of your fourth type. Equations reducible to the equations reduced to fourth type. Okay, equations reducible to fourth type. Okay, and then you have to take this other, in that case you have to take x terms together and y terms together. So q squared minus y is equal to p is taken to other side, so p minus x. Number this equation as 3. Okay, after that you have to find out the complete integral. Our problem is asked to find out the complete integral, so you have to write equation 3 is a separable equation, that you have to write it. After that you have, how will you find out the complete integral? You have to take this to be some constant a squared, isn't it? A squared or a, whatever the term you want to like it. Well, here all the terms are in terms of this term only. Here y is square term is not present, so you take a itself. Okay, if you're taking a square, then you have a square root is here, this term you have a square root. So to avoid that, you take this to be a and equate each to this constant a. Okay, so you have a p minus x is equal to a, and q square minus y is equal to a. After that you have to find out values of p and q, isn't it? So p is equal to a plus x, and q squared is equal to, y is taken to other side, a plus y, or your q is equal to root of a plus y. Okay, and then you have to after finding p, q and values, you have to substitute this in. Dz is equal to p dx plus q dy. Okay, so dz is equal to, what is p value? A plus x into dx. You have to put a bracket here, but because dx is for both the terms. Okay, plus q value is root of a plus y into dy. Now you have to integrate this term. Integral dz is equal to integral a plus x dx plus integral root of a plus y dy. Okay, now we have to integrate this. Integral dz is equal to, this a is constant into dx. Integral dx is x, so ax plus integral x dx is x squared by 2 plus, here we have to apply x power half formula. X power half dx, integral x power half dx. You have to apply x power n formula, n plus 1 formula, isn't it? Sorry, x power n formula. X power n plus 1 divided by n plus 1, you have to use it. So x power 3 by 2 divided by 3 by 2. That is the term you have to write it. So in the place of x, you have a plus y is there. So a plus y whole power 3 by 2 divided by 3 by 2 plus a constant of integration. Okay, or you have ax is equal to, here this side, this is it squared be small, okay, that is this capital z is replaced by small z squared is equal to ax plus x squared by 2 plus this 2 is taken to numerator, 2 into a plus y the whole power 3 by 2 divided by this 3 plus a constant. This is our required complete integral, and this problem also we asked to find out the complete integral alone. So rest of the, if in your depending upon your question, you have to answer it. That's all for this video. If you have any doubts, please provide in the comment section. Thanks for your time and thanks for watching. Thank you.